Let's talk about spatial density maps in R. Let's say that we have a study area that looks like that, and that we have several sites. Let's say that these are trees in a forest. So we have a cluster of trees here and a few more trees that are a little bit more widely dispersed. So when we talk about the spatial density map, all we're trying to do is extrapolate between each of these points, right? If I have these 4 trees here and these 2 trees here, then what do I have right here? Okay, it's trying to make a prediction of how many trees there are. So obviously, if we have sampled all the trees in the forest, this is inappropriate. But if we have sampled, say, every 10th tree, then this would make a little bit more sense. So what we're going to say is, obviously, we have a high cluster of trees here, and it goes out. And so we're kind of building contour lines around our trees, right? So that's a spatial density map. And sometimes they're colored. We say we have high density here, a little bit less density here, and we can move down, a little bit less density here. And so we can end up with a colored map of tree density because we have appropriately sampled every 10th tree or something in the forest. And so we end up with a map that looks something like this. And here's where we have very few trees, right? So that's a spatial density map where we're trying to make a prediction based on our random sampling. We're trying to make a prediction of where trees might be, or what the density of trees might be between locations. All right, building spatial density maps in R is actually really quite easy. Once the data are open, the only command is density. This is actually density.ppp, although R is smart enough to know that if you give it a ppp object, it will use that function to calculate density. All right, let's make this a little bit bigger. So all I'm doing here is formatting my data as a ppp object, which is from the spat library. So here I am cleaning off my workspace. As you can see, I've already been playing with R here. So by cleaning off my workspace, I am making sure I don't have any hidden data or anything that I have had from a previous session. I'm opening up the Baltimore data set from the package spdata. Here I'm extracting just the longitude. Here I'm extracting just the latitude, and I'm doing that because I know down here that's what I need to create the ppp object. I'm opening the spat package, and here I'm creating my data or formatting my data as a ppp object. So ppp object, give the longitude, the latitude, and then the range of the windows in which it sits. So let's just take a quick look at what we've done here. So my data originally are just a spatial data frame, and I could have plotted that with Baltimore plot x versus y, and we'll make that point character 19. So here we have the plot of homes that were for sale for Baltimore in whatever year it was, 1970 something or other. Okay, now that I've created it as a ppp object, when I plot it, it includes the outline, and I have just defined my study area as the line that cuts right through the middle of the easternmost point, the northernmost point, western and southernmost points. So not too dramatic there. It would have been better to get an outline of the city, say. I can also set my point character to 19 if I want it to be filled in points. But there I have my data. I'm going to create a weighted density map in this case, so I'm going to extract the price variable from the Baltimore data set. So this is just the value at which the house was sold when the data were collected. And then I just use the density.ppp function, or since I'm supplying a ppp object, R is smart enough to realize that that's the function I'm calling when I just ask for density. But I'm going to create a density of the Baltimore.ppp object, and I'm going to weight that value by price. So when I do that, oops, I have to create price. When I do that, I now have an object that is an IM object, so it's an image. These are pixels. And if I plot it, I get this map. So you can see I have a greater density of more expensive homes for sale here in the north, and then kind of a ring around that in the downtown area, and then outside of town where I have a lesser dense population of expensive homes. This ribbon over here on the side is, I think I would rather have that on the bottom, so I'm going to set rib side equal to bottom. But other than that, there we go. I could also, and I generally do this, I could also create a contour map over the top of that, which helps me define that a little bit better. But there we go. That's my first way of describing a spatial density map. I could also, I guess, add my points over the top of that if I really wanted to. So there are the individual homes. In this case, I don't think that really adds much, but sometimes it does. Okay, so that's the first way I have of displaying a spatial density map. The second way is to use the perspective plot. And when I do the perspective plot, I just add in the DEN for this is short for density, right? That's what I named it when I created it up here. I'm going to change my colors a little bit. I know, just because I've played with this before, that I really like the terrain colors when their order is reversed. And then you have to establish a theta, which I have set mine to 30, and a phi, which I've set mine equal here to 40. And when you run the perspective plot, let's see, why did that not work? Oh, color ramp. No, color map. There we go. Oh my goodness. You got to get it spelled right, huh? So all I've done here by changing theta, so if I change theta to 50, for example, it just changes the angle at which I am presenting my data, right? And if I change phi over here to 90, it makes it perfectly vertical. I like a little bit of an angle there. There's 25. Let's change this to 25 too. All right. So you have to experiment a little bit to get the combination of angles that creates the picture that you want, but we can see I have a dense population of points of houses here in the top. Okay. The other method that I like to use for displaying spatial density maps is a little bit more complicated. We have to spend a little bit more time creating the color scheme. You have to have the RGL package, and you have to have the class int package, both of them installed and opened. And we have to convert the density map to a matrix, and then we have to transpose it. And then I'm just finding 100 class intervals in that of the data, and then setting up a palette of colors. I'm going to stick with the terrain colors again here, and then assign out those colors. So inside palette, find interval of D based on int, and set that equal to true. Okay, so all of these lines here are set up to create a color scheme so that I can use this command, perspective 3D plot. I want to plot my transposed matrix. I want my color set equal to the colors that I created above. And just to make things clear, I'm going to label my Y label as north, because that's the axis that runs north and south. My X label as east, because that's the axis that runs east and west. And then my Z label, this is the axis that is the density of houses. Okay. So when I run that last line, it opens up this window, which I can drag and make a little bit bigger. But the thing I like about this is now a movable, interactive 3D plot. I can see that I still have my concentration of points here in the north, right? But I can see a little bit better how that relates to the rest of the image, and I can, find the angles and the patterns, or the angles that show me the pattern in the greatest detail. So this is the third way that I sometimes display spatial density maps.